Salutare tuturor, sunt Paul Orha din partea companiei P3. Înainte să încep prezentarea, aș vrea să pun niște întrebări de asemenea, ca să știu cui prezint. Câți dintre voi sunteți developeri? Nice, ok. Și câți dintre voi sunteți... I'll actually switch to English, sorry, for a second. My presentation was originally in Romanian, but we can do English as well. Yeah, so from the developers, how many of you are Android developers or are familiar with Kotlin? Okay, there's someone, awesome. And you're probably familiar with MVVM as well. Okay, great, we have one person, perfect. So, but no worries, because I'll try to discuss more broadly. So the topic of my presentation is mainly unification of state in an application. I discuss mostly about an Android application, but this could be applied to any other platforms, I guess. So for the agenda for today, I will go into describing a support application for this presentation. Then I will discuss about what MVVM is and the ViewModel in the context of MVVM. And then I will discuss the main architecture I want to describe, which is MVI. And then some different states of how you can reach a good MVI architecture. And lastly, we'll do the Q&A session. So I chose as basic an application as I could. So basically we have a screen where you can have a pay and a sum, and then you can like add a transaction with those data. And in case something goes wrong, for example, like the fields are wrong or the call of adding the transaction goes wrong, we can have an error message. So based on this, this is how a classical view model in the MVVM architecture would look like. So basically in MVVM, you have the view model which describes the application itself, what you can do with it without describing the UIs. It's the separation of UI and the rest of the application. In this case, it exposes, for example, the name, the amount, and the possible error that is shown, and also the interactions that the UI layer can have, such as like setting the name and the sum, and then the add action itself. And it also contains some private methods, for example, validating the fields or setting up the error, which is not done by the UI layer directly. Okay, so going on, this is how the add method would look like in the view model context. So basically it does everything from validating the fields, and then if something goes wrong, you can set the error state, and if not, then you can use, for example, I defined a simple use case, which is like an action that does something or in the database layer or an HTTP call, whatever described here as use case. And then based on that result, you can then update the state again. Is it an error? Is it successful? Okay, so the main advantages of this MVVM architecture, which is commonly used in currently most Android applications, is like it's testable. You have the separation of the UI layer and the business logic. And then you also have this responsibility separation. So what is MVI? MVI stands for Model View Intent. Also present in architectures such as Redux. So those who know Redux, this is an equivalent of that, but currently popular in Android development. The main idea is that you have a user and you have a model. The model is the application itself. The user interacts with the model, and then the model shows its data to the user. You could say that this architecture actually applies to all applications or all systems, because that's what you do. You just interact with the system and then it shows you stuff. The idea of the MVI architecture is to put this as the first citizen, to focus on this structure itself in the code layer. So how can you achieve this? Looking at the view model previously for MVVM, you can see clearly that we already have the idea of a model and the idea of intents as shown here. So what you can read from the screen is the model layer, and then the methods themselves are intent. The first step in achieving MVI would be to isolate those separately. It would look something like this. You can use a data class for storing everything about the screen state, and then you can use an interface for describing the different actions you can do. Afterwards, updating the view model, it looks like something like this. The only change is that you publicly expose the whole state instead of separate states. And also you have like a single place where the view sends intents. You don't have different methods. And what's the advantage of this first step? So you have a single source of truth. You have the model which describes the whole application. It's not fragmented. The public API for the view is clear. It's like just 2 instances that are shown. And then you also have easier debugging, but I can get into this maybe another time. So the second step would be extracting pure functions out of the view model. So I would need to first describe what pure functions are. Pure functions in programming are the idea that given a function and some parameters, you always get the same result. And when calling this function, you never do side effects outside of the function context. Why this is useful is because you can easily predict the behavior of the function. You can run them in parallel because it doesn't affect the outside of the scope, and they're very easy to test and debug. So how can we do this in the context of MVI? So this introduces the idea of the reducer, which is also present in Redux architecture. Basically, the reducer is a function that takes a model and an intent, and then generates a new model. For our current setup, this is how the reducer would look like. So it's pretty basic, just updates the model itself based on the fields, and then also can run the validation. And updating the ViewModel, you can see it here, how it looks like. The main important thing here is that you can see that we still have interactions with the model outside of that reducer, because we have to do side effects. As I mentioned previously, we have to add the transaction somewhere. And after adding the transactions, we have to update the model, which you cannot do in a pure context. But the advantage is you now have pure functions. That's a good thing. Going to the third step in obtaining MVI would be, as I described previously, you have the state and you update it via the reducer, but also you can update it via different side effects. It would be ideal if we can update the state only from a single source. This introduces the idea of a store. So the store represents the container where you have the model and where secondary effects like side effects cannot trigger. This is an example of how a model could look like. And also now here I generalized the idea of a reducer to a type alias, so it helps with the code description. Going forward, we can now see that the main thing that changes doing the side effect when you save the transaction. You no longer do it, you no longer edit the state directly here because you send new intents. You have like an intent for after the transaction is added successfully, or if the transactions had an error during the add process. But the side effect is still called in the context of the ViewModel. So also regarding the intents, you saw that I had added a new type of intents, which is like transaction added and an error was present. Those are a bit different because they're not the same intents that the user does. So that's an intent from a side effect. To treat them easier in the code, you can separate them in different classes, so you can still clearly see what are the intents that the user can do. The advantages of this step, mainly you have atomic updates because now everything is done in the store level and it's predictable. The testing and debugging is even better now, and you have now the concept of time travel because the state represents the whole application, I mean the whole screen in this case, and then you have like iterations of the state, and then you can basically treat your application like a movie based on the intent of the user. You have different snapshots of what the app looks like, and you can achieve a lot of things with this feature. Okay, so fourth step, I mentioned in the previous 2 steps the side effects, which are a bit tricky because you can't really use them in a pure function. So to go to the 4th step, which is localizing the side effects, I introduced the concept of effects. So in the upper part, you can see an example of an effect. Basically, an effect does some work in an environment. You can consider this like updating a database or doing an HTTP call or something that has an external effect. And then after it's done working, you have an intent that's returned by the effect. And this is the generalization of the effect idea. So given this, you can now have your reducer no longer return just the model, but now it returns an update. What is an update? So now after user interacts with the application, it does give you the new state, but also does give you the planned actions, side effects that you want to do. So this is how the reducer would look like. The main change is now for the add call, you have the update state exposed, which is different from the previous simple state. We can zoom in on it a bit to see. So basically, this is after the transaction was successfully added. We can update the error state to be gone, but also you can describe the side effect that is going to take place. For example, adding the transaction, and then based on the result, you can send the proper event back to the store. This is not actually running the side effect, it's just describing it. So this is still pure. And then this is how the ViewModel looks like. It's very simple now. It just has the store, it exposes the state of the application, and it handles intent. It's basically unnecessary at this point. Advantages, as I mentioned previously, you have the centralization of side effects. You put them like at the border of your application, and now you could actually say that your, in this case, screen is mostly pure functions. It's just functional programming at this point. Like it gives you a lot of power. For example, like predictable behavior, uniform behavior, easily managing states and errors in a clear stream way. And also the testing and debugging is even easier now, because now all you need to do to debug your application, if you had a crash, you just have the latest state that worked and the intent that caused the crash to happen. You have everything you need to know about why that happened. So what would be the fifth layer? The fifth layer is actually what my article was mostly focused on. Up until now, I just described the single screen, which is in this case the add transaction screen. But what do you do if you want to centralize the state for the whole application? This is what usually applications that convert to MVI stop at, because they localize the store at the screen level, and then they have the whole navigation thing and any other inter screen behavior separate in a classical way. My proposal is to go over to the next step to actually unify everything in a single state. So how I would go about doing that? My easiest way to describe it is like, think about app screens or app. Think about app features. What is a feature in an application? From the presentation I just gave you, I can easily describe a feature as a model. In this case was the add transaction, the intents the user can do, and the reducer, which describes what happens when the user does certain intents. So now that we've clarified the feature, we can now think about combining them. If we think about that the feature can contain multiple sub-features, everything starts to click into place, because every feature has its own reducer, and then you can compose those. And at the end of the day, you have a modular application with different features, but you have a unified state and a unified reducer. This way you can keep all the benefits I described at the screen level of having a functional application, but you can now bring it up to the whole layer without having issues that people mention usually, because I don't want to have a huge model object. Well, you don't. You have different features here. So yeah, this would be described as a single state. That's pretty much it. Thanks for bearing with me during my programming rambling. So if you have any questions.
Okay, any questions? Okay.
I have two questions for you. One was the most exciting thing about this model for you specifically. And secondly, is this something that you can discuss with an end client, or is it like you need to go through a few processes before you actually discuss with the client?
So I didn't really describe what you can enable, what you can enable for a client with this stuff. I will address the second part first. A place where we were able to actually put this to work, or are in the progress of doing that, is we have a request where the client wants all the business logic to be separate from the UI layer, such that in the future, when a completely new UI system, I'm not referring to a new design, but think about a whole new architecture, like using a 3D engine or something like that, can just plug into the old business logic without having to do much change. This architecture of unifying state, so up until now I haven't described UI mostly at all, but you have the whole application business logic here, and then you just have to render the state I described and then to receive the intents back. This means I can plug it in any UI system you want to.
So basically, it's a shortcut.
Yes, it gives you a lot of reusability.
And
also
it helps with user experience. Did I understand correctly?
So regarding user experience directly, it's not actually like the end goal of this. The end goal of this is to have a scalable application that is easily to debug and test. What it helps, I mean, you can achieve the same UI layer for the user, and the other day, the user doesn't know what's behind the system itself. But the important thing is for the client. How can you scale the application? How can you reuse the stuff that you invested so much money into at this point when you want a new UI layer or something? You have like a huge application that's scaled a lot, and you have bugs and you have validations, and then how can you trace what happened in this process? So this architecture enables mostly the developer and client side, not necessarily the end user.
Okay, thank you.
Thank you.
Okay. One dummy question. This is working for Android in general, or are you referring to automotive?
Yeah, so this was general Android. We ended up using this in automotive as well. We achieved different steps on different applications in Android automotive. But this is like a general trend that's happening in Android. I mean, you could say actually happening the whole programming field. We are going towards a functional development infrastructure.
Ah, okay. So
Yeah.
functional, okay.
Yeah, functional is the new.
In Android, okay. Yeah, nice. Good. Any more questions? Let's see. It might be.
From the performance perspective, is it much faster than other architecture?
So it's not necessarily faster, but it could be slower. There are certain things you have to be. Yes. So there are certain caveats you want to take care of, because you can flood the. For example, an important thing that can mainly slow down your application in this case. So I described the whole state of the application as a single model. When you send that to the UI layer, if you then given any small changes, for example, the name in some field changes, the UI layer doesn't know how to handle just that specific change, and it renders the whole screen again, and it's very inefficient. But certain architectures and platforms such as Redux achieved this. You also have in Android you have Jetpack Compose, which does handle this internally, so you don't have to worry about it too much. But yeah, you have to. There are specific, when you get into the nitty-gritty, there are specific concerns regarding performance, and also specific applications concerns. For example, if you have like a huge stream of data, like 60 hertz or something like that, then you might not want to do it everything on a single flow. You might want to offset that somehow and just grab snapshots. So yeah, it's not necessarily faster, I would say.
Okay. Okay, one last question.
Since it follows the MDI pattern like Redux, do you also have a store? And also, can you use reactive programming or reactive operators?
Yes. Yes, so that's the main idea of it. So the reactive side is So as I described the side effects, the effects that are happening, you can reactively manage those in the store when handling different interactions. So the reactive programming is actually the very powerful tool that takes place here, as you know, just as in Redux, so functional and reactive programming. You can use that for the use case layer. You can use that in the whole store itself. Yeah, so it's very important in this context.
Okay, nice. Just one more question.
Yep.
Where is the store kept? I didn't get that part.
So up until the last layer, it's kept at the screen ViewModel layer, because that's how most people address this. If you go to the full state management, you can keep it at the application layer. You can keep it in a service. You can keep it whatever you want, that depending on what lifecycle you want it to have. So you can actually keep it running in the background while the application is not showing at all. It empowers you very much to manage the app lifecycle more than the classic architecture allows you to.
Nice. Thanks.
Okay, let's give Paul a round of applause.
Thank you, everyone.
Actually, do we still have Arthur here or not? It's here? No, okay, so we can switch to Romanian.
A fost mai ușor să vorbesc în engleză, tehnic.
Am văzut, dar am zis că te las, vorbești în engleză, că-ți place. Bun, bine, mulțumim, Paul. Și cu asta o să facem o șmecherie, în sensul că e destul de târziu și ne-am decis să, de comun de acord cu speakerii, am decis să renunțăm la panel, că deja oricum e prea târziu. Dar haideți să premiem cele mai bune întrebări și o să le dăm cumva o invitație la IT Days. Domnișoara de acolo, domnul din spate, ultima întrebare și pare cine? Și Sebi, nu? Haideți în față să vă aplaudăm și să iasă o poză. Și până vin ei, să vă zic o șmecherie, m-am tot jucat cu, cred că ați văzut personajul cu IT Days de anul ăsta și cine vrea să-și bată capul, am pus aici deasupra lui un fel de cod, nu știu dacă l-ați văzut, și, cine îl găsește să ne dă un semnal. Asta ar fi ideea. Bun. Bun, felicitări, haideți să aplaudăm. Îmi trimite-te un e-mail ca să ziceți ceva și mă găsesc în revistă cu adresa. Bun? Bun, felicitări și ne vedem la IT Days. Bun, și încă o chestie, dacă aveți prieteni în Timișoara, o să avem săptămâna viitoare, marți, o lansare în Timișoara și așteptăm și pe ei acolo. Bun, și cu asta cred că încheiem ziua de astăzi, dar mai rămânem prin zonă, mai povestim.